right now, at this very second, there is a statistical probability, and a very high one, actually, that the software routing your company's payroll is just, well, it's not what you think it is.
No, it's definitely not.
Right. Or, the system approving your vendor payments
Hmm.
or moving your customers' highly restricted personal data. That software, it was not built by a software engineer.
Not even close.
Yeah, it wasn't vetted by your cybersecurity team either. It wasn't like load tested by IT. It was probably built by Bob in accounting. Or, Sarah in marketing using some drag and drop tool they learned how to use on YouTube last Thursday.
Just following a quick tutorial and boom, they're routing company funds.
Exactly. And nobody in your IT department even knows it exists. So today, we are going hunting for these invisible systems.
It's a phenomenal shift in how businesses operate today. The corporate brain is kind of moving outside of the traditional IT perimeter, right?
Yeah.
And the people running the business are completely blind to the fragility of what is actually holding their operations together.
That brings us to a scenario I really want you, the listener, to picture. Just imagine you are sitting in a quarterly business review.
Oh, we've all been there.
Right. The projector is humming, and someone is walking you through this slide deck that just reads like an absolute corporate triumph.
The big win.
Yeah, the big win. The presentation is outlining how your business teams are moving, faster than ever before. They're building their own lightweight application.
We're so empowered now.
Right. They are spinning up their own automated workflows to handle data entry and lead routing and approvals. And the metric they're celebrating the absolute most.
I bet I know what it is.
It's the IT support queue. It's actively shrinking. People are just solving their own problems. And it's being pitched as the realization of this ultimate modern enterprise dream, the citizen developer revolution.
The citizen developer, the buzzword of the decade.
Exactly. The narrative is that your workforce is suddenly empowered, they're agile, and they are totally unblocked.
And if you are sitting in that room, it is very hard not to applaud. I mean, it's the exact story that gets celebrated in every boardroom.
Every vendor conference, too.
Right. Every tech magazine right now is pushing this. It's the democratization of development.
And here's why we're doing this deep dive today. I'm going to drop the twist right here at the top. That slide deck, it's a lie.
A pretty dangerous one, too.
Yeah. Well, maybe not an intentional lie, but it is a massive misdirection. This is not some productivity success story. What you are actually looking at, what you're applauding in that quarterly review, is a massive, hidden, and highly volatile infrastructure risk.
Just waiting to detonate.
Waiting to detonate. That's exactly it.
And detonate really is the right word here.
Yeah.
Because what we are looking at is a phenomenon technically known as low-code sprawl.
Low-code sprawl.
Right. But practically speaking, it is an invisible layer of unaudited, largely ownerless logic that has just quietly, relentlessly wrapped itself around your company's most sensitive data over the last 3 to 5 years.
And that brings us to our mission for today's deep dive. We have pulled together this massive stack of operational insights, technical research, platform architecture manuals, and strategic analysis.
A lot of really dense material.
A ton of it. And our goal is to map out exactly where this shadow infrastructure is hiding in your specific organization. But, we're not just going to sit here and admire the problem.
No, we need to fix it.
Right. More importantly, we are going to arm you with a very specific, actionable 48-hour experiment.
I love this experiment so much.
It's brilliant. This is a surgical strike you can run on Monday morning to expose these internal governance risks, prove the danger mathematically to your leadership team, and regain control before, a critical workflow silently breaks.
And takes your payroll down with it.
Or your customer commitments. It's terrifying. But to really grasp the scale and the danger of what we are dealing with here, we need a strong way to visualize it, don't you think?
Absolutely. Because when we talk about software, people still have this image of, lines of green code scrolling on a black screen in a basement somewhere.
Like the Matrix.
Right, exactly like the Matrix.
Really?
But this isn't just about messy code anymore. It's about structural deception.
Structural deception. I like that. And yes, the visual metaphor from the research is absolutely brilliant, and we really need to lock this in our minds.
That's the best way to understand it.
So I want you to imagine a very specific design aesthetic. Think of a classic Dieter Rams-inspired industrial design.
Very clean, very minimalist.
Right. Imagine you were standing in front of a pristine, brushed aluminum enterprise control panel, It is beautiful in its absolute simplicity. You've got these clean, elegant, matte finish buttons, evenly spaced out.
Sounds expensive.
Very expensive. And one button says onboarding, another says procurement, another says time off request. It just looks incredibly orderly. It looks perfectly useful, highly engineered, and completely governed.
It looks safe.
Exactly. It looks safe. But imagine you take a screwdriver and you lift that sleek brushed aluminum faceplate right off the console.
This is where it gets scary.
Yeah. If you look underneath that clean surface, what you actually find is a horrifying, chaotic, tangled web of hidden dependencies. You find orphan wires just like sparking against each other.
Just a total mess.
Total mess. You find logic nodes that lead nowhere. You find unauthorized bridges built out of like duct tape connecting the marketing server directly to the finance database.
Which should never, ever happen.
Never. And you see silent red warning lights flashing in the dark that no one has checked in years.
And that visual metaphor, the pristine brushed aluminum masking the tangled, sparking wires, that is not an exaggeration. That is literally what modern enterprise software looks like today.
It's just wild to think about.
It is. The visible surface, that clean aluminum panel, is the so-called empowered business user clicking a friendly button on a low-code dashboard.
Right. They see the clean button.
But the chaotic wiring underneath is the reality of low-code sprawl. And what is most fascinating, and terrifying, is that the people pressing those clean buttons on the surface have absolutely no idea how fragile the wiring underneath has become.
They just assume someone else is managing it.
Exactly. They just know that when they press the button, the light turns green.
So let's unpack this. We need to really dissect this illusion of empowerment versus the reality of infrastructure. Let's start with that front stage narrative we were just talking about.
The shiny buttons.
Right. Business units love to show off their new tools. I mean, I've seen it firsthand. Marketing has a new form they built over the weekend that automatically categorizes incoming sales leads based on geography.
Very clever.
Super clever.
Yeah.
Or HR built a workflow that automatically provisions Microsoft 365 licenses and sends welcome emails to new hires. Finance has a script that pulls data from 3 different cloud spreadsheets, runs a reconciliation formula, and dumps it into a final report.
And it looks amazing.
On the front stage, yeah, it looks like peak operational maturity. It feels like everyone in the company has suddenly been granted these incredible coding superpowers.
And let's be fair here. We shouldn't dismiss the value of that front stage. I mean, the speed they're achieving is real.
Yeah, they're moving fast.
Very fast.
Yeah.
And the local, granular problem solving is real too. Marketing knows what marketing needs much better than an IT architect does.
That's a good point.
Right. But the issue is entirely what is happening backstage. The structural bottleneck here is that you now have hundreds, and in larger enterprises, tens of thousands of applications bypassing central IT entirely.
Okay, so when you say bypassing IT, what does that practically mean for the organization, like on a day-to-day basis?
It means they are bypassing formal engineering discipline, period. When a software engineer builds an application, they adhere to shared standards. There's a standard for how data is accessed.
Right, and how it's encrypted.
Yes, encryption is huge. There is a standard for logging, meaning there is a permanent record of who did what and when they did it. There is a standard for lifecycle management.
Which non-engineers don't even think about.
Exactly. In the low-code world, because these citizen developers don't have engineering backgrounds, those standards simply do not exist. There is no mechanism to know what happens to that HR onboarding app when the HR coordinator who built it leaves the company next month.
Okay, I want to try an analogy here because I think it helps ground this for the listener. Isn't this just like letting anyone in the company, let's stick with Bob from accounting or Sarah from marketing, build an extension onto the corporate office building without a permit?
Oh, that's good.
Right, without an architect and without even telling the facilities manager. Sure, Bob gets a really nice new corner office. He's very productive in it.
He loves his new office.
He does, but the facilities manager doesn't know if the foundation can hold the weight. He doesn't know if Babe just wired his new overhead lights directly into the main server room's backup power supply.
That is a remarkably accurate analogy.
Yeah.
Because Bob is not a structural engineer, He doesn't know what a load-bearing wall is. He just knows he needs a room to do his job, and he found some drywall and a hammer.
And you went to town.
He did. And if we connect this analogy to the broader enterprise landscape, the sheer scale of this unpermitted construction is staggering.
Give me some numbers.
We are talking about 1 or 2 rogue offices here. We are talking about whole cities being built in the dark. If we look at the Gartner forecasts driving our research today, the numbers should make any executive stop in their tracks.
Okay, lay it on me.
By the years 2025 to 2026, it is projected that 70 to 75% of all new enterprise applications will be built using low-code or no-code tools.
Wait, 70 to 75%?
Yep.
We aren't talking about a fringe trend. That is the vast, overwhelming majority of new enterprise software.
The overwhelming majority. But the more critical statistic is who is building it. Roughly 80% of the users building those new applications will sit entirely outside of formal IT departments.
Wow, 80%.
Yes. They will not report to the chief information officer. They will not think of themselves as engineers or developers. They are marketers, financial analysts, supply chain coordinators, and HR specialists.
Regular business users.
Right. They are building the majority of the company's new operational logic. And they have absolutely zero training in systems architecture, threat modeling, or data governance.
Okay, let me advocate for Bob for a second here.
Sure, let's hear from Bob.
Let's say Bob from accounting builds a rogue app to automatically order new whiteboard markers and coffee filters every month. If that unpermitted construction collapses, what's the real damage?
Not much in that case.
Right. We run out of highlighters for a week. People get a little grumpy about the coffee. The stakes are incredibly low. Is it really a problem if 80% of the company is just building glorified supply closets?
Well, if they were only building supply closets, we wouldn't be having this deep dive today. The danger isn't the tool itself, right? The danger is what the tool is allowed to touch. Your question leads us directly into the heart of the risk. There is an exact moment, a highly specific transition point, when a cute, helpful little side project mutates into a massive corporate liability.
When does that happen?
It's when these citizen-built workflows begin touching sensitive systems. We are not talking about whiteboard markers anymore. We're talking about workflows that suddenly start routing payroll data.
Okay, that's a huge jump.
It is. Workflows that manage vendor payment gateways, initiate wire transfers, execute binding customer commitments, and move personally identifiable information PII, like social security numbers or medical data.
Right. It's the moment Bob's workflow graduates from ordering coffee to routing a $2 million vendor invoice for approval based on custom logic. Bob just, invented on a Tuesday.
Precisely. When it crosses that line and touches restricted data or core money flows, it stops being a local productivity tool. It becomes enterprise infrastructure. And as the source material forcefully points out, infrastructure without a control layer is just deferred consequence.
Deferred consequence. Let's pause on that phrase for a second. It means you haven't actually succeeded, right? You've just delayed the disaster and you are building up debt.
It is a debt you are compounding every single day, and eventually the bill comes due. And when it does, it's usually in the form of a catastrophic, untraceable failure.
I want to get incredibly specific for the listener right now. I want us to lift that brushed aluminum panel right now and look at the actual wires.
Well, let's do it.
Let's detail out a critical list of red flags for any low-code app that is handling sensitive financial data or PII. If you are listening to this on your commute or sitting at your desk in an enterprise environment, these are the hidden landmines you're currently walking over.
The stuff that should keep you up at night.
Exactly. So the first one the research identifies is something called the Ghost Ship app. Walk me through the exact mechanics of a ghost ship.
The Ghost Ship app is one of the most common and, frankly, one of the most dangerous scenarios we find when we audit enterprise environments. This is a workflow, often a highly complex and deeply embedded one, that was built by an employee who has since left the company.
Oh, no.
Yeah. Let's create a realistic scenario. Imagine a senior financial analyst named David.
Okay, David.
David is brilliant, but he's tired of manually reconciling end-of-month payroll discrepancies across 3 different global regions. So he builds a sophisticated low-code automation. It pulls data from Workday, runs a bunch of complex transformation logic, cross-references it with a massive Excel file on a SharePoint drive, and then pushes the finalized numbers into SAP for payout.
I mean, that sounds incredibly useful. David is a hero.
David is a hero for exactly 2 years, because the app works flawlessly in the background. But then, David takes a promotion at a rival company. He gives his 2 weeks' notice.
Good for David. Bad for the company.
Very bad for the company. On his last day, IT does their standard offboarding. They go into Active Directory, which is essentially the master digital keyring that controls who has access to what in the company, and they disable David's account. His email is shut off. His laptop is wiped.
Standard procedure.
But The low-code platform is often disconnected from that specific offboarding logic. Or worse, David was clever and set the automation to run on a shared service account so it wouldn't be tied to his personal login.
So David is gone, but the app is still running. It's literally a ghost ship sailing itself.
It is sailing itself, and it is carrying the company's payroll. No one currently employed at the company actually knows how the automation works. The underlying logic is a complete black box to the current finance team.
They just assume it's magic.
They just know that on the 30th of the month, the numbers magically appear in SAP. But what happens 6 months later when Workday updates its API, the way systems talk to each other? Or what happens when the SharePoint drive gets migrated to a new server?
I'm guessing the app fails?
It fails silently. It doesn't send an error message to IT because IT doesn't own it. The first time anyone realizes something is wrong is when 300 employees in the European division don't get their paychecks on Friday morning.
That is a nightmare scenario.
And when the panicked finance team calls the IT help desk, IT looks at the systems and says, "Everything looks fine on our end. What automation are you talking about?" The architect is gone, the blueprints are gone, and the system is down.
That is genuinely terrifying. A ghost ship moving company money. Okay, let's look at red flag number 2. Zero review history. How does this differ from traditional software development?
Right, so if a formal software engineer writes a script to move money, let's say a script to calculate sales commissions,
Yeah,
that code does not just go straight into the live environment.
it has to be tested, right?
Exactly. It goes through a rigorous process. It goes through peer review where another engineer reads the code. It goes through security testing to ensure it can't be hacked. It goes through quality assurance testing to make sure the math is right.
It's a whole assembly line of checks.
But in the citizen developer world, if a business analyst builds the exact same commission calculating logic in a low-code canvas, they often just hit the publish button.
Just one click?
One click. There is no second set of eyes. There is no security review.
So they are acting as the architect, the builder, and the building inspector all at once.
Yes. And humans make mistakes. A simple typo in a formula, a misplaced decimal point, or pulling from the gross revenue column instead of the net margin column could bleed capital for months before anyone notices. It has never been vetted by anyone in engineering, finance governance, or cybersecurity.
I see. It's the equivalent of Bob building his office extension and just deciding on his own that the electrical wiring looks good enough and plugging it straight into the wall.
And hoping the building doesn't burn down.
Right. Let's move to red flag number 3, which seems to strike at the heart of our tangled wire metaphor: blind dependencies.
Blind dependencies are where the low-code sprawl truly creates systemic cascading risk. A blind dependency means an application is built in such a way that it is totally unclear what other systems will break if this specific workflow goes down.
Give me an example of that.
Let's say Sarah in operations builds an automation that triggers an email notification whenever a new enterprise client signs a contract. It seems innocent enough.
Right, just a basic alert system, nothing crazy.
But Sarah's automation is so useful that over the next year, other citizen developers start using it as a foundational block.
Oh, I see where this is going.
The provisioning team builds an app that triggers off of Sarah's email to automatically set up the client's cloud environment. The billing team builds an app that triggers off of Sarah's email to generate the first invoice. The compliance team builds an app that triggers off of Sarah's email to run a background check.
Oh, wow. So Sarah's little email alert is now a load-bearing pillar for 4 different departments.
And none of them told each other they were doing this. They just quietly hooked their wires into Sarah's wire. Now, let's say Sarah decides to change the subject line of her email alert, or she accidentally deletes the app.
The email stops sending.
The email stops sending, which means the cloud environment never gets provisioned, the first invoice never gets sent, and the background check never runs. It causes a cascading failure across the business.
A massive chain reaction.
And because central IT has no map of these blind dependencies, they have no way to trace the failure back to its origin. They are staring at a massive outage, flying completely blind, trying to untangle a ball of yarn that is actively on fire.
That paints a painfully clear picture. The last red flag we need to highlight before we move on is no attached policy. What does that look like in practice?
This means that critical, sensitive workflows are operating completely outside of corporate compliance rules or data classification standards.
Like regulatory stuff?
Exactly. A classic example involves data residency laws, like GDPR in Europe, which mandate that European citizen data must stay on European servers. An ambitious marketing coordinator might build a low-code flow that pulls thousands of European customer records out of a highly secure, geographically locked database and dumps them into a shared Excel file sitting on a US-based cloud server so they can run a quick mail merge campaign
And they just instantly violated international data privacy laws.
in a matter of seconds. And it wasn't malicious.
They were just trying to do their job.
Right. The citizen developer simply didn't know the policy existed, and because the low-code platform had no overarching governance attached to it, the tool didn't stop them. It just happily moved the restricted data exactly where they told it to.
I need to play devil's advocate here for a second, because if I am a chief financial officer or a VP of sales listening to this, I am going to push back.
Of course.
I hear you. The ghost ships, the blind dependencies, the compliance risks. It sounds messy. But let's look at the reality on the ground. If these apps are working right now, if the invoices are actually getting paid, the emails are sending, and my team is looking me in the eye and telling me they're saving 50 hours a week of manual data entry.
It's hard to argue with that.
Right. Is it really that urgent? Can't we just let it run? Aren't you, as the IT expert, just fear-mongering about hypothetical API changes and theoretical compliance audits to justify slowing down my business?
I completely understand that perspective. And honestly, it is the most common pushback we hear from the business side. But I'd argue it is a dangerous illusion based on survivorship bias.
Survivorship bias? How so?
You are only looking at the apps that haven't failed yet. Let's go back to that phrase, deferred consequence. The urgency isn't that the app is broken today. The urgency is the catastrophic cost of the inevitable failure.
Walk me through that. If it saves me 50 hours a week for 2 years, maybe the failure is worth it.
Not if the failure happens during a Q2 capital bleed, where millions of dollars are routed to the wrong vendor accounts because a decimal point shifted in an unvetted formula.
Ouch.
Right. Not if the failure happens during a massive regulatory audit and the auditors discover that thousands of Social Security numbers are sitting in an unsecured, unlogged database built by an intern 3 years ago.
Yeah.
The fines alone would wipe out any productivity gains your team made over the last decade.
So it's a ticking time bomb.
It works seamlessly right up until it silently fails at the worst possible time. The core issue is that you have no mechanism to know if it breaks, why it broke, or who is responsible for fixing it. You are driving a car at 100 miles an hour with the dashboard taped over.
Driving with the dashboard taped over. I like that. Okay, so if I'm the Chief Information Security Officer, the CISO, and you just explained to me that my company's filled with ghost ships, blind dependencies, and regulatory landmines, my first instinct is going to be incredibly violent. I want to hit the kill switch. Tomorrow morning, I want to ban all these low-code tools. I want to revoke the licenses, lock down the permissions, and issue a company-wide memo saying, nobody builds anything, ever, unless it goes through a 6-month formal IT review.
And that instinct, while completely emotionally understandable for a CISO, is actually the worst possible strategic move you could make. It will backfire spectacularly.
Why? Wouldn't it just stop the bleeding?
To understand why banning these tools fails, we need to look at the ecosystem. We need to ask, who actually benefits from this obscurity? And what happens to human behavior when you try to prohibit a tool that people rely on?
Let's follow the money then. Who is actually winning in this current state of chaos? Because if it's a mess that clearly serves somebody's interests. Otherwise, it wouldn't have grown to 75% of all new applications.
There are 3 primary beneficiaries of the current low-code mess. First, you have the low-code vendors themselves. Let's be clear about their business model.
They want to sell licenses.
They are highly incentivized to sell licenses, drive up seat capacity, and sell the dream of instant enablement directly to business unit leaders. They bypass IT on purpose. They celebrate the raw adoption metrics. Look how many flows your team built this month.
But they don't take on the risk.
Not at all. They completely offload the downstream governance risk to your organization. If an ownerless app breaks your payroll, you can't sue the vendor. They just provided the canvas.
They sell you the lumber, the nails, and the hammer. But they take absolutely no responsibility if the house you build collapses on your head.
Exactly right. The second beneficiary is the systems integrators, or external consultants. They come in, set up the initial platforms, run a few highly publicized training workshops, and build the first few shiny brushed aluminum dashboards to show the executives.
Getting those early wins.
They get paid handsomely for the initial setup and the digital transformation win. But they don't stick around to own the operational risk 3 years later when the original citizen developers have all quit and the workflows start failing.
It's a hit-and-run digital transformation.
And finally, the third beneficiary is the internal business teams themselves. The marketing, HR, and finance teams. They enjoy the immediate gratification of speed. They get their local granular problems solved today. And, crucially, they get to operate with a temporary lack of accountability.
Because nobody's watching them.
Because IT doesn't know what they are building, they don't have to answer to security audits, they don't have to write documentation, and they don't have to wait in line.
The obscurity is working for all three of them. The vendor gets paid, the consultant gets paid, and the business unit gets to move fast without oversight. So, back to my CISO kill switch. The CISO sees this unholy alliance, panics, and issues an outright ban on low-code platforms. Why does that fail?
Because bans rarely remove demand, they just remove visibility. Think about the fundamental pressure on a modern business. Speed is not a luxury, it is a requirement.
Right. You have to move fast.
Let's say the sanctioned IT path to get a new workflow built takes 9 months and requires a massive budget approval process. But the marketing team has a mandate from the CEO to launch a massive new customer campaign tomorrow. And they need a way to route that customer data. They are not going to wait 9 months.
Right. If they wait 9 months, they miss the quarter, and they lose their bonuses, they're going to find a way to route that data tomorrow.
Always. Water finds a crack. If you ban the officially sanctioned enterprise-grade low-code platforms, people will still need to move data and get approvals. They will just push the activity deeper into shadow operations.
It's like what? What do they use instead?
They will use their personal Dropbox accounts. They will write massive, macro-heavy Excel spreadsheets that get passed around on unencrypted USB drives. Or they will simply use corporate credit cards to buy unvetted third-party SaaS tools that the CISO has never even heard of.
Which is infinitely worse.
A ban doesn't stop the dangerous activity. It just ensures that when the inevitable data breach or failure happens, you are completely, utterly blind to it.
You force the unpermitted construction underground. So if we can't ban it because that just creates a worse shadow IT problem, and we can't let it run wild because that leads to catastrophic deferred consequence, what is the real control point? What is the middle path?
The only sustainable strategy must be legitimation with controls. You have to keep the speed because the business genuinely needs it to survive, but you have to add legibility.
Let's define legibility carefully because it's a recurring theme in the research. It's not just visibility, right? It's not just seeing that the app is there.
Right. Think of a tangled ball of yarn. It is highly visible. You can see it sitting right there on the table, but it is not legible. You cannot trace a single thread from beginning to end. You don't know how long it is or what it's tied to.
You just see a mess.
Legibility means you can read and understand the system. You need an environment where citizen developers can still build quickly, but they build within an invisible safety net that automatically maps ownership, enforces data policies, and tracks dependencies. You need to be able to untangle the yarn.
Okay, conceptually, I am completely sold. Legitimation with controls, legibility. But here's the practical problem. How do you actually prove this to a skeptical leadership team?
That's the hard part.
Right. If you were a mid-level IP manager or an enterprise architect and you walk into the C-suite and start lecturing them about legitimation with controls and legibility, the CEO is going to roll their eyes. They will just see it as IT complaining about losing control of the budget again. How do you prove that this invisible theoretical problem is real, pressing, and happening right down the hall?
You don't ask for a massive transformation budget. You don't launch a global 6-month cross-functional task force to study the problem. You run a surgical strike. You prove it with irrefutable local data.
This is the moment we've been building toward. This is where we get to the core actionable takeaway for you, the listener. If you take nothing else away from this deep dive, take this. We are going to outline a cheap, fast, 48-hour asymmetric bet.
It's so effective.
It really is. This is a specific test you can run starting Monday morning to expose your internal governance risks without disrupting the business and without having to ask a committee for permission. Let's unpack the 48-hour experiment. Walk me through Monday morning, day 1.
Let's break it down step by step. Day 1 is the inventory. The absolute most important rule of day 1 is do not try to boil the ocean.
Keep it small.
If you try to audit the entire company's software footprint, you will fail, and it will take 6 months. Instead, you pick just one specific business function. Finance or HR are universally the best candidates.
Why finance or HR specifically? Why not marketing?
Because the workflows built by finance and HR inherently touch highly sensitive regulated data. Marketing might be moving lead lists, but HR is moving Social Security numbers and finance is moving millions of dollars. The stakes are instantly recognizable to any executive.
Got it.
So let's say you pick finance. Your first step on Monday morning is to run a discovery process across your primary platforms, whether that's Microsoft Power Automate, Salesforce, or whatever your company uses. You just want a raw inventory of all the apps, forms, and automations currently active in the finance department's environment.
Okay, so I run the scan, and maybe I get a massive list. Let's say I find 500 different little apps, dashboards, and workflows.
Right. Now you have to filter that list. You are panning for gold, but in this case, the gold is risk. You apply your first filter. Isolate only the workflows that are actively touching PII, payroll systems, vendor payment gateways, or core financial databases.
So anything touching money or sensitive data.
Exactly. You throw out the 400 apps that are just ordering office supplies or organizing team lunches.
So my list of 500 drops significantly. Let's say I'm down to 60 apps that are handling real money or highly sensitive employee data. What's the next step?
Now, you apply the final critical filter by asking the red flag questions we discussed earlier. You look at those 60 apps one by one, and you ask 4 things.
Okay, what are they?
1, is there a clear, currently employed human owner assigned to this app in the system? 2, is there any documented security or code review history? 3, is there dependency visibility? Can I easily see what upstream or downstream systems this touches? And 4, is there any corporate governance policies strictly attached to it?
And the ones that fail those questions.
You isolate the failures. That final count, let's say it's 14 apps. 14 apps actively touching money or sensitive data with no active owner, no review history, blind dependencies, and no governance. That number is your actual mathematically proven risk surface.
I love this analogy we were discussing in our prep for this deep dive. Running this experiment is exactly like turning on a blacklight in a supposedly clean hotel room.
Oh yeah, it's gross but accurate.
Right. When you walk into a hotel room, it looks pristine. The bed is made, the counters are wiped down. But if you suspect the cleaning staff is cutting corners, you don't need to get a magnifying glass and inspect every square inch of the carpet. You just turn off the overhead lights, turn on a UV black light, and shine it in one corner next to the bed.
And you just pray you don't see anything.
Exactly. But if you see a terrifying amount of glowing spots in that one single corner, you have mathematically proven that the hotel has a systemic cleaning problem. You don't need to check the whole room to prove the thesis.
That is a visceral, slightly horrifying, but incredibly accurate way to look at it.
Yeah.
The 48-hour experiment is your blacklight. If you run this discovery in the finance department and your final number of unowned risky apps is greater than 0, and I can guarantee you, based on industry averages, it will be much greater than 0. Your thesis is validated.
It's no longer hypothetical.
You are no longer talking about a theoretical infrastructure risk. You have hard, undeniable evidence of deferred consequence operating right now.
Okay, so the black light is on. It's Monday afternoon. I am staring at a spreadsheet showing 14 ownerless apps, including a ghost ship left behind by our former senior analyst, David, that are actively routing company payroll right now. I am mildly panicked, but I have my data.
You have your ammunition.
Day 1 is over. Now day 2 begins. The pitch. How do I walk into the CIO's office on Tuesday morning without sounding like Chicken Little screaming that the sky is falling? Because if it just sounds like a complaint, they will dismiss me.
You are absolutely right. It cannot be framed as a complaint. Executives ignore complaints, they fund solutions. Day 2 must be framed as a strategic proposal, specifically a governance pilot proposal. You walk into the office of the CIO, and ideally you bring the chief financial officer or the chief HR officer with you, since it's their data at risk.
Bring the stakeholders.
Always. And you do not speak in abstract theories about low-code sprawl. You put the blacklight evidence right on the desk.
You literally point to the spreadsheet. We ran a limited scan. We found a payroll routing automation currently active, moving $500,000 a month, built by an employee who left 2 years ago with 0 security review history.
Yes, you make the risk tangible and undeniable. But immediately after you present the fear, you must shift the narrative to the solution. You look at the CIO and you tell them, the company does not have a low-code adoption problem. The adoption is fantastic. Our people are innovating. What we have is a legibility problem.
That's a great pivot.
You forcefully reframe citizen development.
Yeah.
You move it away from a productivity story, which is how the vendors and the marketing team talk about it. And you redefine it as an infrastructure story.
You're changing the vocabulary. It's not a toy. It's the plumbing.
Exactly. And then you frame your proposed solution as an asymmetric advantage.
What does that mean in this context? How does this pitch offer the CIO an asymmetric advantage?
You explain the broader market reality. You say, the enterprise that wins in the next 5 years is not the one that aggressively bans low-code apps. And it's certainly not the one that lets them run wild until they cause a massive data breach. The winner is the company that can discover, classify, and control these apps without killing the speed of the business.
So you're selling them on being a pioneer.
You are pitching the CIO on an opportunity to quietly own and shape the future of business process change. Instead of constantly playing whack-a-mole with shadow IT, instead of constantly fighting with business unit leaders who just want to get their jobs done, IT can step in and provide the invisible governance layer that allows the business to go fast, safely.
You are offering the CIO the ultimate control point. You're saying, look, the train has already left the station. We don't need to try and stop the train. That's a losing battle. We just need to build the tracks and the automated signaling system so it doesn't derail and take the company down with it.
Precisely. And that is a pitch any smart CIO desperately wants to hear. It positions the IT department not as the department of not as a bottleneck, but as an enabler of safe velocity. You are proposing a pilot program to build those tracks.
Okay, let's play this out. Let's say the pitch works perfectly. The CIO looks at the 14 ownerless money-moving apps, turns pale, realizes you are right, and says, yes, you have the budget, do the pilot, build the safety net.
That's the dream.
This is where the rubber meets the road. The IT developers, the enterprise architects, they actually have to sit down and build this thing. What does that safety net practically look like? Because we aren't just telling people to be more careful, we are building a system.
This is where we transition into the technical checklist for workflow security. And the foundational concept everyone needs to grasp here is that the next valuable layer of enterprise software is not another builder tool. We don't need another drag-and-drop canvas for Bob to play with.
God knows we have plenty of those.
We have far too many. What is desperately needed is a cross-platform governance and runtime control layer. It is a system that sits above or across all the different low-code platforms your company uses, whether that's Microsoft, Salesforce, Appian, ServiceNow, whatever.
Let's translate the source materials capability stack into a concrete technical checklist. If I am an IT director tasked with securing this mess, what are the 5 things I absolutely must build or buy? Item 1 on the checklist. Cross-platform discovery and registry. How does this work?
This is the foundation of legibility. You cannot govern what you cannot see. So you need to deploy connectors and metadata collectors that actively scan across all those different platforms.
Like a radar sweep.
Think of it like a universal translator. Microsoft speaks one language, Salesforce speaks another. The discovery tool translates them all and pulls every single app, flow, and automation into a single, centralized, constantly updating registry. It becomes your master inventory list.
So no more hiding in the shadows. If it exists on the network, it's in the registry. Item 2, static analysis for low code. Now, I know the term static analysis from traditional software engineering. It means analyzing the code without actually running the program. But what does it mean in a visual drag-and-drop environment?
It's a great question. In traditional code, static analysis scans the lines of text for known vulnerabilities. In low code, there isn't traditional code to read. But beneath every visual block Bob drags onto a screen, the platform is automatically generating configuration files, usually in a format called JSON or XML.
The hidden blueprint.
These are basically the raw text files acting as the architectural blueprints. So the static analysis tools need to be tuned specifically to read those underlying JSON blueprints. They are scanning for low-code specific mistakes.
Give me an example of what they're looking for.
For example, they look for hard-coded credentials. Did a citizen developer type an API password in plain text right into a workflow step where anyone could read it? Or they look for insecure data movement. Is a flow configured to pull PII from a secure SQL database and automatically email it to a public Gmail address?
Oh, wow. So it's essentially an automated, tireless code reviewer that understands exactly how non-engineers make stupid, dangerous mistakes.
Exactly. It catches the errors before they happen.
That is huge. Okay, item 3 on the checklist. Owner mapping and lifecycle controls. This sounds like the direct antidote to the ghost ship problem we talked about earlier.
It is the exact cure for the ghost ship. The system must enforce a rule that every single app in the registry is mapped to an active human owner or a specific monitored team queue. And crucially, this mapping must be dynamically tied into your identity management system, like Active Directory.
Explain how that dynamic tie works. What happens when David quits in this scenario?
Let's run the David scenario again, but with this system in place, David puts in his 2 weeks. On his last day, IT disables his Active Directory account. Instantly, the lifecycle control system registers that status change.
It knows he's gone.
It automatically scans the registry and flags every single app David owned. It pauses any critical financial flows immediately to prevent unmonitored execution. And most importantly, it routes an automated alert to David's former manager saying, "David's gone. These 6 apps are now orphaned. You have 48 hours to assign a new owner or they will be permanently deactivated."
That is brilliant. It immediately stops the deferred consequence from accumulating. You never have an app running silently in the dark for 2 years without an owner ever again. It forces accountability.
Yes, exactly.
Let's move to item 4, policy engine and review workflows. This feels like the part where we actually balance the speed of the business with the safety of IT.
That is exactly the balance. You cannot review every single app or you will crush the agility of the company. So you build a policy engine that applies contextual friction. You attach policy templates based on data classification and process criticality.
Contextual friction, how does that work in practice?
Let me give you the contrast. A marketing intern builds a simple web form to collect sandwich orders for a Friday lunch. When they try to publish it, the policy engine scans the underlying JSON. It sees no PII, no financial connections, no external APIs.
This totally says.
It classifies the risk as 0, and it auto-approves the deployment instantly. 0 friction. The intern gets their lunch form immediately.
The speed is completely maintained for the low-risk stuff.
Exactly. But an hour later, a finance analyst builds a workflow that attempts to connect to the core payroll database and execute external API calls to a third-party vendor. When they hit publish, the policy engine scans it, flags the high-risk connections, and pauses the deployment.
It hits the brakes.
It tells the analyst, this touches restricted systems. It has been routed to the IT security queue for a mandatory, lightweight security review. It routes the right amount of friction to the right place.
Contextual friction, that is such a powerful concept. It treats a squirt gun differently than a loaded weapon. And finally, the last item on the technical checklist, dependency dashboards.
This is the visual map of those tangled wires beneath the aluminum panel. It's a dashboard that shows if workflow A goes down, it will sever the connection to application B, which will crash automation C.
So no more blind dependencies.
This is vital for incident response. When a failure inevitably happens, the IT team doesn't have to spend 3 frantic days trying to trace the logic manually while the CEO yells at them. They pull up the dashboard and it shows them the exact blast radius of the failure instantly.
If we step back and look at this whole checklist, cross-platform discovery, static analysis, owner mapping, contextual policy engines, and dependency dashboards, what we've done is entirely transform an unmanaged, dangerous mess into a legible, governable asset.
We brought it into the light.
We've taken the rogue citizen developers, all the unpermitted builders like Bob and Sarah, and we've safely brought them back into the fold. And the genius of it is they don't even necessarily know the safety net is there until they try to do something dangerous, at which point the system gently guides them to compliance.
Exactly. You haven't taken away their power. You haven't taken away the engine. You've simply given their vehicle a steering wheel and a set of functional brakes.
This has been an incredibly dense and valuable deep dive. Let's quickly retrace the journey we've been on. We started by peeling back the illusion of empowerment, looking past the pristine brushed aluminum control panel to reveal the chaotic, dangerous wiring of low-code sprawl underneath.
The structural deception.
Right. We identified the severe financial red flags hiding in the shadows, the ghost ships sailing without captains, the workflows with 0 review history, the blind dependencies, and the massive compliance violations.
From there, we laid out the 48-hour discovery experiment. The practical, Monday morning blacklight test to find your actual, mathematically proven risk surface in finance or HR.
We talked about how to take that terrifying data, walk into the CIO's office on Tuesday, and pitch a strategic governance pilot by shifting the narrative from a productivity story to an infrastructure story.
And finally, we detailed the technical checklist for building a new control layer, a system of true legibility that allows the business to maintain its speed while dramatically reducing its hidden risk through things like static analysis and contextual policy engines.
The overarching, inescapable takeaway is clear. As an enterprise leader, you must not confuse low-code adoption with operational control.
They are 2 entirely different things. High adoption just means people are building fast. It doesn't mean they are building safe.
Right.
The real winner here, the asymmetric advantage in the market, belongs to the companies that recognize this structural shift early. The companies that see this late are going to learn their lesson the hard way. They will learn it through a massive public compliance failure, a leaked customer data set, or a broken financial flow that makes headlines and ends careers.
Which nobody wants.
But the ones that see it early, the ones who build that governance and legibility layer right now, will quietly capture the ultimate control point of modern enterprise operations.
They will own the infrastructure of the future, while everyone else is just playing with toys. As we wrap up this deep dive, I want to leave you, the listener, with a final, slightly provocative thought to chew on. Something that goes beyond today's crisis and looks at tomorrow's.
Oh, this is the scary part.
It is. We've used this Dieter Rams lens of less but better to think about enterprise software. We want our systems to be clean, ordered, legible, and governed. But if we look at the reality of citizen developers rapidly spinning up thousands of these micro applications to solve momentary problems, are they actually making the company more agile?
Or are they just creating more debt?
Exactly. Are they just rapidly, enthusiastically increasing the amount of invisible technical debt that the next generation of software engineers is going to have to spend a decade cleaning up?
It is a profound, almost philosophical question. By bypassing traditional engineering, we are essentially democratizing the creation of technical debt at an industrial scale.
And I want to take it one step further because this is where it gets truly wild. Everything we discussed today, all the risks, the ghost ships, the unpermitted construction, that was all about human employees. Sarah in marketing, Bob in finance, David the analyst. Humans are relatively slow.
Compared to computers, yeah.
What happens in the next 12 to 18 months when AI agents, not just human employees, start building these undocumented workflows on the fly?
Oh, man.
Right? When an AI assistant decides it needs a new data bridge to answer a user's prompt and it just writes the low-code script itself in 3 seconds. If your control panel is a mess of tangled wires right now because of humans, what happens when machines start adding their own wiring in the dark 1,000 times faster?
If you don't have that legibility layer established, tested, and running right now, the introduction of AI-driven development will not just be a risk. It will turn your sprawl into an absolute unnavigable labyrinth. The time to build the map is before the machines start building the maze.
It is time to lift up that beautiful brushed aluminum faceplate. Take a long, hard look beneath the surface of your own company's control panel. Run the 48-hour experiment. Find out what is really running your business before it stops running altogether.